I'm the new Catholic chaplain at MIT, just started in September. Father Michael Meadus, I'm a priest of the Archdiocese of Boston. And it's been a tremendous several months being the Catholic chaplain at MIT. So inspiring for me, the faith of the students and the faculty. And I really, in just a brief amount of time, it has become clear to me what a special place the Tech Catholic community has within the larger MIT community. And that's where this idea of having a lecture that would honor alumni came to birth, came to light, is that the wonderful, inspiring messages and life that the Tech Catholic community offers, that you all are that life. There's that beautiful chapel building and so many great events that happen, but none of that would happen without you walking into the building and bringing Catholic faith to life at MIT. So this lecture this evening is really in honor of all of the alumni. And we're so grateful that we're able to do this, particularly from the generosity of the Catherine McLaughlin Highcomb Fund that has been established for this kind of lecture series. So we're so grateful for Dr. Ray Highcomb, who provided that fund to us and made this opportunity possible. I'd like to introduce to you one of the members of the Tech Catholic community, Keith Montcrief. Keith is from Illinois. He's presently a junior at MIT, Course 8 Physics, and Keith will introduce our speaker.
Hello, everyone. So our speaker is Michelle M. Francel, PhD. She is the Frank B. Mallory Professor of Chemistry at Bryn Mawr College, where she has been on the faculty since 1986, and an adjunct scholar of the Vatican Observatory. She's a quantum chemist who has published in areas ranging from the development of methods for computational chemistry to the structures of topologically intriguing molecules. Dr. Francel is also a writer whose essays on science, culture, and policy appear regularly in Nature Chemistry and in several collections. She was elected a Fellow of the American Chemical Society in 2009 and is the 2019 recipient of the ACS Philadelphia Section Award. In addition to Dr. Francel's scientific work, she has authored numerous articles on Catholic spirituality, an audiobook titled Great Catholic Scientists, Discoveries and Lives of Faith, in collaboration with MIT graduate and director of the Vatican Observatory, Brother Guy Consolmagno, and a soon-to-be published book on prayer entitled Prayer, Biblical Wisdom for Seeking God. Excelling in science and faith, it is our honor to welcome Dr. Michelle Francel.
Thank you so much for that lovely introduction, Keith, and to Father Michael and the community for the invitation to give this talk. And I'm going to share my screen here and see if we can get started. There we go. All right. So the title of my talk tonight is Amid the Burning Layers of Grace, Science as Prayer. And I'd like to make the case that science and faith are connected at the bench level, so to speak, and not just at sort of the philosophical level. So I'd like us to think specifically about praying as scientists. And like poets, we dig into the universe and try to wrap words and equations around things that are infinite and perhaps at some level unknowable. So this advice from poet Wendell Berry might be apt for us as well. The whole rest of the poem is pretty apt for scientists. It describes the struggles to sort of try to wrap your mind around things that are infinite and sometimes have limits beyond something that we can touch. Our labs are sacred spaces, as sacred as our churches, and we would do well to remember that. So this is a quote from Laudato Si, which prejudice should not have us criticize those who seek ecstasy in music or poetry, and I might add, or science. There is a subtle mystery in these movements, and there's a subtle mystery in the work that we do in the laboratory as well. The title from this talk comes from this quote, which is taken from 20th century theologian and geologist, paleontologist, and Jesuit priest, Pierre Teilhard de Chardin, and it's from his posthumously published book, The Divine Milieu. It captures, for me at least, what it means to do science as a spiritual practice, as prayer. I want to make the case tonight for considering science as prayer and as contemplative prayer in particular. And in doing so, to think about what the mystics might have to offer science, but also to think about what science might have to offer the mystics. So to start with, science, as we all know, is not a book of facts. And in the same way, religion is not a book of rules. And they're both very human endeavors, ways of wrestling with the universe and our relationship to it. And as much as we want to say as scientists that we are objective, that we are part of the created universe, and so we really can't completely separate ourselves out from the science. As much as we would like to be Vulcan, we are really not. And I might expand on Heisenberg here and say that it's not just part of the interplay with nature and ourselves, but the interplay between ourselves and God. I'm going to take a moment here to tell you where I'm coming from so you have some idea. So as Keith said, I'm a quantum mechanic. So if you have broken quantums, please forward them. I repair them and as needed basis. But I'm a scientist, a Christian, a practicing Roman Catholic. I would characterize myself as a contemplative. So someone who finds time to be in silence and to be still. I regularly try to find ways to extricate myself from the interwebs, harder to do in these times of the pandemic when everything is on Zoom. And my own spiritual practice really draws very strongly from the wells of the 3rd and 4th century desert solitaries, Abba Poemen, Amma Synclectica, and their struggles with distractions and the attempts to balance the solitary life, the contemplative life, with a life of hospitality and the concomitant interruptions that are inherent to the work of teaching and the work of research. And also their willingness to stand on the edge of what is known, on the edge of the desert with their hands open, resonate deeply with my own life as a teacher and as a woman of faith and as a scientific researcher. I'm going to say that the Psalms were the spears that these contemplatives wielded with fervor and joy. And for me, the Psalms form a really deep part of my faith life. There's a local Augustinian community that celebrates the Liturgy of the Hours, and that has been the bedrock of my psalmody for many, many years. As a scientist, though, I get caught again and again by those images in the psalm of the creative world. The hoarfrost is scattered like ashes, and bees harass the unwary, and snails trail glimmering slime. So I'm a theorist, and I'm a theorist that has a taste for surprise. So I love this quote from Henry James. There are two kinds of taste in the appreciation of imaginative literature, and I would say in the imagination of the world, the taste for emotions of surprise and the taste for emotions of recognition. And I think chemists often have a taste for emotions of recognition. We're very pattern driven and thinking about reactivity and structure. But personally, I have a taste for surprise, and I'm interested in structures of molecules that don't follow the rules that chemists think they ought to follow. One of the joys of being a theorist is the constraints on the molecules I work with are different than those from experiment. And they're really just limited by my imagination and the size of the computational resource I can get my hands on. This is a sketch of Thomas Merton by Thomas Merton. And really for me, prayer is everything. So when we think about St. Paul's exhortation to pray at all times, we breathe at all times, and we pray at all times. And for me, that's in or out of the laboratory, in and out of my office, in and out of the kitchen. Prayer is the breath that sustains me. So a little map of tonight's talk. I'm going to briefly talk about science and faith and the relationship between them. Then I want to talk about prayer. And then finally, I want to talk about the perspectives that I think that contemplatives might have to offer scientists, and vice versa, what scientists might have to offer contemplatives. I'm going to point out this is not a talk about philosophy, and it's not a science talk, and it's actually probably not really a theology talk, except perhaps as theology is faith-seeking understanding. This is really a reflection on practice, what one might do. And I'd like to frame the question in the following ways. First of all, how can science, whether it's work in the laboratory or the field, be prayer? What, if anything, might contemplatives have to offer scientists practically? And again, practically, what might scientists have to say to contemplatives? What perspectives might one have that would enrich the other approach? And I want to be careful in both these things to keep the door open to non-theists, to people who don't believe in God, but to also avoid collapsing science and faith, science and religion into a single entity. They are different things, different approaches. So science and faith. And there's often a common misperception that science and faith are somehow at war with each other. But I like this picture because here, see if I can get the tech to work. There are two domes. The dome of St. Thomas of Villanova and Castle Gandolfo, and the domes from the Specula, from the observatories, vintage telescopes that are also on the roof. And what I love about this picture is that science and faith are sharing space, and they're sharing perspective. They're both overlooking the lake, and this is really the way in which I see science and faith, as sharing space. So there's this notion that, good Christians should beware mathematicians. I will point out I'm married to a mathematician, and I'm the mother of another mathematician. And certainly some of my students occasionally think in the middle of a quantum mechanics class that this is somewhat demonic. But Augustine here actually is not really talking about what we would call mathematicians, but really about astrologers. Scientists are not heretics, they're not ensnared by demons, and nor are people of faith crazy, believing in utterly unprovable things. So these people would be surprised to think that somehow we would think that science and faith were at war with each other. So that's Abbot John Klassen of the Abbey in Collegeville, Minnesota, the Abbey of St. John's. That is Elizabeth Lund, who for a long time was a Buddhist nun. That's Gregor Mendel, an Augustinian. That's Brother Guy Consolmagno. That's a very famous chemist that I'm hoping everyone recognizes. And these people as well. So the sisters that worked on the Celestial Mapping Project, who are here. Antoni Gaudí. This is Sister Mary Keller, who got first PhD in computer science, or first woman to get a PhD in computer science. Brother Bob Mackey. This is Father David Brown at the telescope, the dome on top of Castle Gandolfo. This is Sister Kathy Duffy, who's a physicist. None of these people would consider science and faith to be at war with each other. I love this quote from Paul VI, which comes at the closing of Vatican II in the midst of the space race. He essentially makes the point that we are all out for a walk in the universe, and that we will likely bump into each other, whether we are scientists or people of faith or both. We're all seeking the truth, and neither side should wear blinders. We should be aware that there are other searchers of good faith, even if we would not count them among the faithful. The church still thinks that she has something to offer from her rich treasuries of experience, from the scripture to the desert fathers and mothers, to Hildegard of Bingen, and to my astronomer colleagues at the Specula. So as tempting as it is to think of science and religion in opposition, the ultimate battle between facts and faith, At their core, they are both ways in which humans grapple with the fundamental questions of existence. Why is there something instead of nothing? Why is there this particular universe? Is there only one universe? Why are we in the universe? And how do we, individually and together, work with and within the tangible world? As I said before, I want to be careful not to collapse science and faith into a single entity. They're different approaches, they're not disconnected. And I might argue that even if you don't believe in God, religion still serves a purpose vis-a-vis science. These are not new ideas by any means. Science and faith are both about truth, and I would just point out that truth can't contradict itself. If they seem at odds, then it's demand to go deeper, not to dig deeper into transpositions, but to dig deeper into God and dig deeper into the mystery. So I promised I would talk about prayer and talk about approaching scientific research as prayer. So here we go. And this is Father Giuseppe, this is the chapel at the Specula. So this is the one place where I can go to mass, where everybody is a physicist around the table. Tech is probably another spot you could do that too. And I'm only a little bit jealous of that. So I'd like to define prayer, and I'm going to lean on the Catechism of the Catholic Church for this. To me, at its core, prayer is the act of turning toward God, responding in love to the one who created us. In prayer, not only do we call out to God, but God endlessly calls out to us, ever enfolding us in mercy and drawing us close in love. And I've highlighted a couple of things here. Prayer is the raising of one's mind and heart to God, or the requesting of good things from God. And I think all of us as researchers probably at one time or another have prayed for good results on an experiment or on a calculation. But I think we've also probably all raised our minds to think about, what is in this created world? And the Catechism of the Catholic Church points out that it is the whole person who prays. There is not one person that prays at church and someone else who goes to the lab and does science. We pray as we are, as who we are. And it is not really solely our work, but it is the work that comes both from ourselves and the Holy Spirit. You can split prayer up in any number of ways. And here is, an entire medley of ways of praying. I just finished writing a book on prayer, and the biggest frustration was there is so much to say, and there was a page limit. And so when I submitted the manuscript, they were like, oh, you have to make, a chunk of this manuscript go away. And it cost me pain to take out things. And even doing that, I barely scraped the surface. But I want to talk about contemplative prayer. So to be upfront, this notion that scientific research has a contemplative aspect, which is certainly not mine alone, but it's definitely biased by my own scholarly work and my own spiritual practices. Because my chemistry research is focused on molecules that misbehave, whose structures and reactivities are in some way unexpected, it's an area of research that demands I look at what is there and accept what presents itself, not what I expect to see, not what I hope to see, not what the theory says I should see, not what the organic chemist down the hall says I should see, since that would suggest I shouldn't be seeing it at all, but what's actually in front of me without prejudice. And exercises of these sorts are, of course, familiar to practitioners of many contemplative traditions. You can consider, for example, St. Ignatius of Loyola's notion of indifference. And certainly practitioners of Buddhism would recognize this sitting with what is. I like these two definitions of contemplative prayer. The first comes from Walter Burkhardt, a Jesuit who spent the last part of his career in Philadelphia, who referred to contemplative prayer as a long, loving look at the real. And I like this definition in particular because it strikes me as a really good definition of science as well. Science is a long, loving look at the real. We are passionate about what we do, and what we do is to consider what's in front of us, the real. But I also like St. Therese of Lisieux's definition. A surge of the heart, a simple look toward heaven. It is a cry of recognition and of love, embracing both trial and joy. And certainly those sound many strings that are familiar to work in science. There is trial and there is joy. There are cries of recognition when we see something that we've been looking for a long time, and certainly surges of inspiration. So this frame works for me for both prayer as well as research. So there's this beautiful quote by St. John Damascene, which one sees all over the place. The whole earth is a living icon of the face of God. And it turns out, as far as we can tell, St. John of Damascus never actually said quite this. But it remains to do science, to think deeply about the universe that surrounds us, is in fact to contemplate it. And thus making scientists, at least those who might believe in God, contemplatives or mystics. So one question we could pose is, are scientists mystics? And in posing it in that way, I mean to kind of shake the boundaries a little bit, to shake loose the preconceptions that we have about what mystics are and what scientists are, and maybe to make each side kind of bristle a bit at that description. I also want to be mindful as I go to keep the conversation perhaps broad enough to encompass those for whom God doesn't feel like a participant, where mystic isn't a thing. So maybe one might stick with contemplative. So this is really an old notion, and it probably goes back as far as the Catholic Church goes. So this is a painting of St. Anthony of the Desert, St. Anthony the Great, who lived in the 3rd and 4th centuries, and is often called the father of monasticism. I will point out this is a very, there's a lot of anachronisms in this picture. So reading glasses did not appear until the 13th century. And this is a 15th century portrait. Also, St. Anthony was sort of known for his ascetic qualities, so I doubt he had such fancy robes to work with. But the point nonetheless is still valid. My book is the nature of created things, and as often as I have mind to read the words of God, they are at my hand. So we have at our hand the ability to do Lectio Divina with nature, to read the hand of God in creation. St. Teresa of Avila, who was a 16th century Carmelite mystic, and she had mystical experiences in the kitchen, which really upset her fellow sisters. You know, she's supposed to be doing the dishes. She's not supposed to be having a mystical experience. And when they sort of chided her for that, she responded with, know that even when you're in the kitchen, our Lord moves amid the pots and the pans. But we could equally well say that know that even when you are in the laboratory, our Lord moves amidst the beakers and flasks. Again, we put artificial boundaries around what we consider sacred space and what we consider sacred tasks. But Teresa of Avila is suggesting that no task is not sacred, and no task is left alone by the Lord. So what does this look like in practice? I kind of promised something about practice. So practical advice for the impractical. And I have 3 pieces of advice, perhaps from the contemplatives, that might find utility in thinking about prayer as, or scientific research as prayer. And the first is this awareness of multiple dimensions, multiple readings of nature. A second is a non-judgmental view, which probably seems like exactly the view we would like to have as scientists. And the last is an unforced pace. The photo here is of the hermitage of Nakamura-san, who was a scientist turned hermit and artist, who lives on a mountaintop in Japan, about a 2-mile walk up the mountain. And, you know, he thinks hard about these relationships between scientific research and what it means to live a contemplative life. So the first is this notion of multiple readings of things. I should ask Bob to tell us what the sample is, because it's
Stichodia lean. It fell in Russia. It's a shattered. It's a basically a piece of metallic shrapnel.
Thank you. Yes. I actually had that at the bottom, but it's much better to have you here to tell us what it is. But I want us to think about being comfortable with multiple readings. So chemist and philosopher Michael Polanyi summed up kind of the enigma. We know more than we can say. So what is it to talk about the indescribable? There's more to phenomena than we can quantify. And what we can see and touch is a portal into things we can't see and touch, and which we often lack the words to describe. And I want to point out that modern science has kind of stripped itself of the words that it needs to describe things beyond the measurable. In particular, we've really ceased to rely on the five senses. What does that meteorite feel like? We have a measurement of its size, we can measure its heat capacity, we can measure its density. If you can't give it a number, if it can't be measured, is it really science? If you go back and look through the chemical literature, it used to be routine to report not only the odor of the substance you were making, but also its taste. Compounds are reported smelling of wet dog fur, and intermediates along a synthetic route might be characterized by their changing odors. You should smell the sharp smell of ammonia. Amino acids smelled or tasted sweet and astringent, for better, at least in the case of taste, or for worse. These descriptions have really vanished from the scientific literature. And to point out the extent to which they've really vanished, there's a recent paper about the synthesis of ionones, which are a substance that's responsible for the smell of violets. So these were scented compounds intended as perfume components. So they're meant to smell. And nowhere in the article do the authors actually use the word smell or odor or anything indicating that these things might have a smell. And it's only on page 120 of the supplementary information that they directly acknowledge that someone actually smelled the compounds. And yes, they smell like violets. So I'd like us to think about what is it that we know about the science that we do beyond what it is that we can measure. There's a beautiful poem by Marilyn Nelson called Dusting. This is a small piece of it. And I think about it when I dust my office. And what exactly is it that I am dusting off of my desk? And it's much more than you might think. The unpolished and the ordinary is often cloaked in the extraordinary. And that's something that as scientists, we often have the privilege to understand in ways that we might not if we did not do the work that we do. So as an example, this is a plate from John Larson's book on meteorites. It's called In Search of Stardust. And John Larson wondered if you could find micrometeorites on the tops of buildings or other flat spaces. And in Norway, in fact, he looked for these things, and you can. And these are beautiful. And these are scattered across the top of the buildings we're in right now. I could go out my roof, presumably, and collect some of these things. And if I looked carefully enough, this is the beauty that I would see. So tiny tokens of the universe are settling on us all the time. And crumbs of the infinite kind of lie scattered wherever we touch. And we're just not always aware of it as something beautiful, even if we're aware of it from the scientific perspective. In his book, Encounters in Silence, Karl Rahner reflected that if there's any path at all on which I can approach God, approach you, it must lead through the middle of my very ordinary daily life. I'm not sure that you could describe Karl Rahner's life as ordinary, and I'm not sure that you could necessarily describe the things that many of us work with as particularly ordinary. But dusting reminds me that our daily life, even when it is unremarkable or unremarkable to us, is not so ordinary. Fragments of God and creation are strewn wherever we walk. So we can measure an NMR coupling constant, we can simulate a protein, we can find the structure of an interesting molecule, and we can read it as science, but we can also read it as a fragment of God. We can also read it as a way to see into the mind of God, part of that back and forth dialogue. So simply to see. Attention is the rarest and purest form of generosity, said Simone Weil. The truth is concrete or particular. So the truth is not written in bold strokes, but in the details. So if we think about this, the notion of being keen observers and observers of the particular is another way into prayer, another way into the truth. Robert Boyle was a really vocal champion of doing research, as he said, in the presence of an illustrious assembly, and thought that the standard procedure for publishing work ought to be that you conduct the experiment in public with an illustrious assembly watching. He very gradually came to the recognition that this was a bit impractical, but he continued to champion concrete particularity, that using vivid descriptions, using woodcut illustrations that included not only the apparatus that was being worked with, but sometimes inconsequential details that serve to create the illusion that one's actually present to what's occurring. So as abstract as some of the scientific work we do is, we always experience it as something that's concrete, as something particular. We don't work with schematics, but with actual instruments, computer codes, and materials. And one contemplative practice that trains us to appreciate this richness of description and of particulars is to have this eye for detail. St. Ignatius of Loyola talks about this as the composition of place. So when you make the spiritual exercises, he encourages you to bring this awareness of these multiple dimensions and of the particularity of a place to bear on the contemplations of scriptures. And the same thing goes for us with scientific research, to think not just about the particulars that are in front of us that pertain to the science, but also the wider range in which they are embedded. 1,000 years before Ignatius of Loyola, Bessarion, one of the Desert Fathers, taught that a monk ought to be like cherubim and seraphim, all eye, and scientists should be the same, all eye for more than just the science. So if you would be a scientist, Lawrence Ferlinghetti would suggest that you should avoid limiting your descriptions of results, graphs, and materials to a stilted and scientific subset of the language, but be a bit flamboyant, be a bit over the top, at least in the privacy of your own records. So this attentiveness gives us access to the universe in a form that's not been reduced to skeletal notations, and it keeps the real, the truth within the particulars, front and center. A scientist ought to be like the cherubim and seraphim, all eye, even for things that maybe do not always fall within the purview of science. And I wanted to point out that there's always a moral dimension to what we do. I think often of this quote from Laudato Si, that the goal is not just to satisfy our curiosity about the universe, but also to be painfully aware of where we're failing to care for our brothers and sisters, and to look not only to satisfy our curiosity about the universe, but also to reach out to alleviate the suffering of those who live within it. So an unforced pace, this is the last thing I think, well, there are other things I think, but last thing I'm going to say about what I think contemplative prayer might have to offer scientists. Thomas Mertens said that the rush and pressure of modern life are a form, perhaps the most common form, of its innate violence. And I'll point out that he was saying this in the 1950s and 60s. So modern life has gotten, I think, only faster since then. To allow oneself to be carried away by a multitude of conflicting concerns, to surrender to too many demands, to commit oneself to too many projects, guilty, 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 to want to help everyone in everything is in fact to succumb to violence. It kills the root of inner wisdom, which makes work fruitful. This is the Trappist monk, Thomas Merton. We think of science as fast and frantic, I think, and most of us may have experienced as that. We're invested not just in publishing our results, but often in publishing them quickly. My own field, the Journal of the American Chemical Society, now has an online section to the journal. It's called ASAP, as soon as possible. They promise 24 hours after the editor signed off on it, it will be up and available. And I think we're really aware of this in this particular moment in time. You know, Operation Warp Speed to produce vaccines, of course, has done that, exactly that. It took less than a week, in fact, to create the new mRNA vaccines. The rest of the time really has just been logistics and safety testing. But that said, it's not clear that a fast pace is as productive of science as we think it is. The historian of science, Gerald Halton, notes that key developments in science often depend on this unforced pace of work, a skill the contemplatives have in full measure. And I'd like to suggest that we see science as more than a series of competitions with heart-stopping races to arbitrary finish lines, but to also learn to value slow science, where the pace is driven by the needs of the work and not the need to find an answer ASAP. To the graduate students who want to get out, my graduate students want everything ASAP because they want to be finished. But there's something to say about letting the work direct the pace. So I show this picture at various talks and I ask people to tell me what it is. So what are those people doing? Any thoughts?
Looks like they're sitting drinking tea.
Ah, sitting drinking tea. Okay. It could be doing that. Could they be texting? To me, that's what this looks like. It's a bunch of people sitting there holding their phones and texting. It's of course, something from the Metropolitan Museum of Art, and I forget when it dates to, but it dates long before there were cell phones. But in this moment where we can sort of access anything almost instantly, what can we do to foster an ability to be patient, not rushed, to have time to think, to have a thoughtfulness about what and how the work will proceed, and to have a certain amount of internal spaciousness. So in her book, The Cloister Walk, Kathleen Norris, who spent time at St. John's Abbey, where Abbot John Klassen, who's a chemist, infrared spectroscopist, is the abbot. She wondered when she came back how to keep as much of the monastery in her as possible. How could she draw on the scaffold that St. Benedict had produced for monks for a monastic life outside the wall? And one of the things she noted is that the ceremonies of monastic life tended to slow things down. They were a bit of an antidote to frenzy. And scientists also know how to wait. I mean, if you think about, the probes that we're sending off to Cassini or Juno, or those people who are interested in materials which change on a really long time scale. So I had an earlier slide where I had a picture of a pitch tar dropping. And that experiment's been going on for 100 years, and I think they've recorded 8 drops of the pitch. So even though when the distance and time involved don't dictate the pace, the reward for slowing down can be substantial. And maybe I will tell us a story. This is a bit of a Philadelphia history story. So in early November of 1895, while experimenting with fluorescence from a Crookes tube, William Röntgen noticed that a surface coated with a fluorescent barium salt, so a platinobarium cyanide actually, glowed whenever the tube was discharged, even when the surface was shielded from the light source, which made him begin to think that maybe there was some other invisible emission from the tube that was able to penetrate the shade that he had on the light. So he stopped what he was doing and he just played with it. He didn't have a particular deadline, he just kind of played. And he noticed, among other things, that these rays could penetrate a 1,000-page book as easily as a glass plate. And really wildly, when he waved his hand between the source and the screen, he realized he could see the shadow of his bones. And he spent about 7 weeks playing before he made any report to even the local scientific society. But what he showed at that scientific society was this picture of his wife's hand with the ring on it. And interestingly, within just weeks of that being published, physicians began using the X-ray in clinical practice. So 7 weeks of kind of monastic isolation playing with the phenomena led to the discovery of the X-ray, or did it? So these are Crookes tubes. These are made of minerals that will react with X-rays, and this is what they look like with the X-rays on. Amazingly enough, people kept these in their living rooms and made little X-ray sources right there in your living room. I try not to think about that. But one can look at this picture here as well. So the two physicists at the University of Pennsylvania had been doing physics demonstrations for the evening. And at the end, one of them said, "Hey, I want to show you these Crookes tubes. Look at these. These are really cool." And in the rush to go look at this and get their stuff gathered up and take the trolley home, he threw his trolley fare on top of his stack of photographic plates and mixed up both the exposed and unexposed plates. And when he brought them back the next day, he realized that all of the plates had been exposed. He developed them all and figured, some of them would be blank and some of them would not be. But in addition to the images that he expected to see, there were negatives with these weird, strange discs on them. So if you look here, there are these 2 discs here. And this one is quite clear, very clear edges to it. And so Jennings and Goodspeed. And Jennings and Goodspeed exchanged a few telegrams trying to figure out what happened. But after 3 or 4 days, they just dropped the question when no clear answer emerged. I also love the telegrams or the email of the late 19th century. What they had was the first X-ray. And while rushing may have led to their error, it also led to the failure to see it for what it was. And when Brunton's picture was published in the Philadelphia paper, they knew immediately what they had. And they went and they dragged the plate out, looked at it, realized that they in fact had taken the first X-ray. And they wrote to Röntgen, who said, "Yep, you did," but they missed it. An unforced pace is sometimes worth it. Annie Diller talks about this in her book, The Writing Life, that, not everything can or should be rushed. And there might be a few people who can do things fast, but we ought not to take human extremes as norms. So I want to flip this around. What can contemplatives learn from scientists? And I'm going to say that there are 3 things, I think. That a willingness to find beauty in the strange, that doubt is not the enemy, and that we can live with uncertainty. This is a quote from Edward Purcell's Nobel Prize lecture in 1952. This is for the discovery of nuclear magnetic resonance. And this beauty, to see the world for a moment as something rich and strange, is the private reward of many a discovery. And I think that all of us as scientists have had that experience probably pretty regularly, that what we see when we look at a glass of water or at a piece of material is different. I can imagine, if I look at the meteorite, I have some sense of what its history is, but Bob, for whom this is his specialty, if he looks at that meteorite, there's layers and layers of wonder and delight in that, as that only really those who work with these materials have access to. So there's an ability to see beauty even in the things that we might not consider beautiful. These are my top 10 most beautiful molecules. And if you are not a chemist, you might look at these and say, right, never mind. But all of these are in one way or another to me quite beautiful. What we don't know drives us as scientists. It's what draws us in. It's a bug, not a feature, or it's a feature, not a bug. The gospel this week was about doubting Thomas, and that doubt is what led eventually Thomas to declare, "My Lord and my God." Doubt is what drives scientists too. Someone in this audience might recognize a picture of himself, and his question is there enough money in your pocket for a gelato? This is a yes or no, and basically an uninteresting question. Although at this moment, I would give a lot for a gelato. But this notion that questions that just have simple yes or no answers are not mysterious enough to draw us in. And scientists are excited by mystery and not daunted by it. And doubt, being uncertain of the answer, is something that drives our curiosity. This is a picture, and you can see, I think, a little bit. It's crossed hands of my niece, and it turned out there was a partial solar eclipse occurring that we didn't know was going to be happening. I spent the last week and a half in a monastery, and my dad didn't particularly follow the news. And so I showed her, when you crossed your hands, you can see these extra little kind of curves in here, these weird shadows that you get with an eclipse. But this really sparked her curiosity, what's happening? These are the mysteries that drive scientists and that we're not uncomfortable with. Theologian Paul Tillich, doubt is not the opposite of faith, it's one element of faith. And I think that's something that the scientists were comfortable with, doubt and uncertainty, in ways that I think our brothers and sisters might benefit from understanding. So the last is uncertainty. This is a standing joke in my house. I can find my car keys, but my spouse cannot, and it's probably because he knows too much about their momentum. But we understand that not everything about the physical universe is knowable, or at least quantifiable. Building a better measuring device is not going to overrule the Heisenberg uncertainty principle. And again, this is the same issue that many people face with faith, that there are some things that ultimately are unknowable, but yet we believe. So the flip to this, of course, is that theological formation is a gradual and often painful discovery of God's incomprehensibility. You can be competent in many things, but you cannot be competent in God. And to me, this feels like the Heisenberg uncertainty principle applied to faith. That no matter how much you push at trying to understand God, you are simply going to discover more and more that God is beyond our comprehension. We can come, we can adore, but we will never limit God's being with what we know. So what can contemplatives learn from scientists, aside from how to meditate? Finding beauty in the difficult, a comfort with doubt, and a comfort with uncertainty. But I'll finish by saying that to be able to stammer about God is, after all, more important than to speak exactly about the world. And that for all that we have difficulty wrapping language around what it is we do when we pray, what it is we do when we, all right, there we go. That for all those difficulties, it's still important to try. To see everything we do as a way of prayer. And so I'm going to leave us, I think, by saying that I hope that in exploring the commonalities between contemplative practice and scientific research, scientists, whether they're believers or not, can find approaches that can strengthen and enrich their work. In particular, my aim in making these shared approaches explicit is to enable scientists who are religious, particularly those who find themselves drawn to the contemplative traditions of their own faith, to be able to see their scientific work encompassed within their spiritual lives. We live in a universe gone wild with light, as priest and poet John O'Donohue would have it. We long for light. We long to be immersed in it, to grasp its nuances and vagaries with whatever tools we have to hand, be it prayer or quantum mechanics as prayer. And with that, I'm going to thank everybody and say that I'm happy to answer questions. And I can thank all kinds of people, some of whom are here in the audience, but in particular, the Klaus Fund for Science and Public Policy, which funds a lot of my writing, as well as the National Science Foundation, which funds my chemistry research. And I'm going to thank everyone for their attention.
Thank you so much, Dr. Francel, for inaugurating this beautiful lecture in honor of all of our alumni. I'm so glad that we recorded it because I was cheerfully overwhelmed by so much of what you were able to share. And I was writing down notes and I thought, oh no, what was that exactly? So I'm glad I'm going to be able to go back and continue to mine the beautiful insights that you gave, but particularly with regards to 2 points that are still echoing in my mind and heart.